Okay, so now I explain what is the meaning of 2D arrays and pointers, or what is the relation of 2D arrays and pointers. As you have seen that I have already made some arrangement to make the process a bit faster so that I can explain to you quickly. When we say 2D arrays and pointers, actually 2D arrays also have got a wonderful relation with pointers. What is that? When we write int ANN, I have, for understanding purpose, I have deliberately used two different numbers, m and n. Or maybe you make it very simple, maybe 50 and 30. You have declared something like this, int a 50 30. What happens? What happens automatically? A becomes a pointer. No doubt A is an address. No doubt A is an address. What is that address? Maybe XXXX is that address. So that address is A. In that address A, YYYY is contained. So this is somewhat like an 1D array. If this is A, then this is YYYY. Definitely this itself is A0. Is right? So you compare with a 1D array. If this is A, then this is A0, start of A. Like that, if this is A, then the next location, next available location is A plus 1. No doubt about it. Actually, it is 2 incremented if it is an integer, but I can think of it as A plus 1. If that is so, then this A plus 1, content of A plus 1 is no doubt A1. Do you agree with me? Similarly, if you say next location is A plus 2, like a 1D array, a 1D array is exactly like this, A plus 2, then definitely the content of that is A2. Will you agree with me? Similarly, if this is A plus 3, then no doubt the content of this is A3. I think you agree with me. This is very simple, like a 1D array. Is not it so? Now, what I mean to say is, if that is so, say this is YYYY. So this YYYY in case of a 2D array is actually an address. In case of a 2D array, A0 is also an address. Remember, in case of a 1D array of int star, if A is the address, then definitely A0 is the integer. But in a 2D array, if it is int A 50 30, then definitely A0, A1, A2, A3, all these are themselves addresses. So this YYYY is another address of another location. So remember, if this is A0, then no doubt YYYY also, you can write this is A0, the address is A0. So if this is A, the content of A is A0, then if the address is A0, the content of that is what? A00. Will you agree with me? I repeat. See, if when you declare int A 50 30, A is an address again. So the content of that is A0. A plus 1 content of that is A1, like a 2D, like a 1D array. But difference with a 1D array is A0 over here is another address. A1 is also an address. A2 is also an address. A3 is also an address. So like that, this is A0 an address. So if address is A, content of that is A0. So if the address is A0, content of that is A00. Now remember, if this is A, this is A00, this is A01. So if this is A0, this is A00, and definitely this one is A01. Will you agree with me? See, please understand. Why am I saying that? Very simple. If this is A, then this is A0. So if this is A0, definitely this is A00. If this is A, this is A0, this is A1, this is A2, this is A3, and so on. Similarly, if this is A0, this is A00, this is A01, this is A02, next one is A03, and so on. I think you understand this. Question is how long? See, this is A5030. A5030. So this will continue how long? Till A029. A00 to A029 makes it how many? 30. 30 numbers. So this is A00 to A029. The memory allocations will happen. So I can say this is continue. Sorry, I just delete this part and say that maybe this is continued. This one no doubt is A029. Do you understand? This continue from A00 to A029. Now that means A1 will contain A1, A plus 1 will contain A1. Value of A1 is ZZZZ. Now what is this ZZZZ? All these are generally, as I said, thought in terms of hexadecimal numbers. Now what is this ZZZZ? ZZZZ is this location. ZZZZ is this location. From here starts what? Remember, this is A0. Y. From there starts A00. Continues up to A029. Because we have got A5030. This part is 30. So 0 to 29 is 30. This is ZZZZ, but this is A1. A1 contains this automatically. So this is A1. Remember, so if this is A1, then you understand what is this then? If this is A1, just an adjustment. If this is A1, then what is this? No doubt, if this is A, this is A0. So if this is A1, then definitely this one is A10. Do you understand this? This is how the numbers are arranged automatically. So if this is A10, then definitely this one is A11. Sorry, I will just create a bit of space. So this one is A11. I think you understand this. A11. So tell me, how long will this continue again? This will continue till we reach A129. I think you understand, because it is A5030. Have a look over there. This is A5030, this one. So 0 to 29 makes it 30. So A10 to A129. So what is this? Think of this one as maybe something else, maybe Q. Just any name I'm giving. So this Q actually is this one, A2. Understand this. This one is Q, A2. So definitely you understand this one is A2. So if this is A2, what is this? A20. How long does this continue? Till A29. In this way, next one will be A3. So do you understand? This thing happens automatically. Now how long does this continue? This continues till A plus 49. What is A plus 49? No doubt the content of A plus 49 is A49. The content of the address A plus 49 is always A49. So this will if this is A49 and if this contains maybe R, so this continues in this way, and maybe sometimes or the other we reach after a lot of maybe A20 to A229, A30 to A329. In this way, I will sometimes reach A49. What is that A49? That one R. The content of R. What should be the content? If this is A49, then this is A49 0. How long to continue? This to continue till A49 29. So this is how the array is arranged internally. When you write int A5030, believe me, such a huge thing occurs automatically within the system. This whole thing happens automatically within the system. Firstly, there is a 1D array, that is constituted like this: A0, A1, A2, A3 and so on up to A49 if you declare this as A5030. So this continues from A0 to A49. A 1D array is constituted. But this array is an array of pointers, array of addresses, not an array of integers. Now this array of addresses definitely contains these addresses. These addresses in turn contains the integer that you have talked about over here. A00, 01, 02 and so on. This is 02. 02 and so on continues up to 029. Similarly, A1, 10, 11 up to A129 continued up to here. But these addresses are contained over here. So do you understand this whole thing? Now you tell me, when you declare a 1D array, like say int A50, what is A? What is the nature of A? A is a pointer. The nature of A is int star A. A is a pointer to an integer. So similarly, when you are writing int A5030, what is the nature of A? You see, A is an address. That address contains another address, and that address contains an integer. Yes, A is an address. That address contains another address. That address contains an integer. So don't you think over here A is no doubt a pointer to a pointer? Is not so? Similarly, what is A0? When you declare int A5030, what is A0? A0 is basically a pointer to an integer. A0 is basically pointed to an integer because A0 contains an address and that address contains an integer. So I think you understand this. Is not so? Is not so? So this whole thing is actually constituted internally automatically, which means that if you have to change, if you now have to change your way of writing, you want to avoid writing int A5030 for the same reason. You want to avoid writing int A5030 for the same reason. Why do you want to avoid writing int A5030? Because if you write int A5030, automatically inside how many memory locations are created? 50 into 30, 1500 into 2. Each integer contains is contained in 2 memory locations. So int A5030 will mean that it is making 50 into 30, 1500 integers, and one integer is 2 memory locations, so 3000 memory locations will be taken. Then you say, okay, my number of rows is 4 and number of columns is 5. So basically you are going to use 4 into 5, 20 integer space, that is 40 memory locations. And for that you have allocated how many? You have allocated 3000 memory locations. Generally we were hash defining n as 100 and we were declaring int n. Think, when we were hash defining n 100 and declaring over here int nn, what does that mean? 100 into 100 makes it 10,000. 10,000 integers, that is 20,000 memory locations you are allocating inside. And then you are saying 4 rows and 5 columns. That is 4 into 5, 20 integers, that is 40 memory locations. And for that you are allocating 20,000 memory locations. A total waste of space you are doing in your program, which is not necessary, which is not generally done. Because you will be writing bigger programs day by day. You don't want to waste memory locations. Suppose you are playing a game. For that game also some code has been written inside. If that code allocates a lot of memory locations, then your game will be slow. So number of memory locations should be least used. In the same way you can think, suppose you declare int 100, but user says I need 200 rows and 300 columns. So even your int 100 is not enough. You need more space than that. So you allocate exactly that amount of space which has been told by the user. If user says m rows and n columns, then you actually allocate m rows and n columns. That is m into n into 2. That many you allocate. So over here, the replacement of, here you have used int a 5030, which has done an allocation of this amount of memory locations. Instead of writing int a 5030, then what can I write? See, this whole thing now I am writing using pointers. I will firstly write int star star a, because remember a is pointer to a pointer. It contains an address. That address again contains another address. That address contains an integer. So it is pointer to a pointer in star star a. Now I will have to allocate these spaces. Is not it so? How many such spaces? Suppose you ask for the user, enter the number of rows and columns. Now you tell the user printf, enter number of rows and columns. This is what you tell the user. Enter number of rows and columns. Once you tell that, now you scanf %d followed by ampersand m and ampersand n. You scan it inside. After entering the number of rows and columns, now you scan. Now what will happen after scanning? M and n means this 50 and 30 you have not used. You have scanned 50 and 30. So instead of 15 and 30, suppose user has entered only 5 and 4. So you need how many spaces over here? Here you are needing 50 spaces. But user enters 5 and 4. So how many space over here will you need? Only 5. See, for int a 5030, you are allocating 50 spaces here. So here how many space do you need? User has entered 5 and 4. So here you will need only 5 spaces. A0, A1, A2, A3, A4. Is not it so? These will be called A0, A1, A2, A3, A4. So what you do now is, firstly you allocate A is equal to, what is the typecasting of A? In star star. It's a pointer to a pointer. Then malloc. How many space do you need? You need 5. Like for int a 5030, you are needing A0 to A49. 50 spaces. Here you need only 5 spaces. Where is 5? In M. So how many space do you need? Malloc M into size of what? Size of what? M into. This is M into, that is 5 into. Size of what? Each of these are what? Each of these are pointers, not integers. So not size of int, but size of int star. Remember, these are all pointers to integers. So these are these are int star. So I need to write M into size of int star. Int star star malloc M into size of int star. These are M memory locations I need. M pointer to integers I need. So M into size of int star. Once this is allocated, once this A is allocated, now this allocation has to be done. How many spaces do you need to allocate over here now? How many spaces do you need to allocate now? M into n. But where to receive it? This is A0, remember. This is A0. You need to receive it over here. So A0 has to now allocate M into n memory locations. Isn't it? So M into n integers. So M into n into size of int. So A0 is equal to int star malloc, because A0 is pointed to integer. Malloc M into n into size of int. Why am I doing all this? I could have written simple int a nn only to avoid allocating extra space. Remember, now I have allocated all these integer spaces, but one step is now left out. What is that? That is A1, A2, A3, all these needs to be initialized also. A1 should contain this address where from A10 should start. if you don't allocate, if you don't make A1 equal to Z, 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 till now what have you done? You have done A, you have allocated A. This is Y, 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 you have allocated this entire space. This entire space has been allocated. Then this entire space has been allocated. This address has been assigned over here. One step left out. That is, all these addresses need to be allocated. This Z, 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 Z should go to A1. If you don't do that, then you cannot access this by A10. This cannot be accessed by A10. So this Z, 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 Z should be assigned over here to A1. Is not so? So what to do now? You now need a for loop. A0 has been allocated. Now for I equal to 1 for every AI, I less than m, I plus plus. What I need to do is, I need to now allocate AI, assign the value to AI. What is AI? AI minus 1, see this, plus n into size of int. See this, interesting. Why did I write like this? What is A1? A1 is, what is the value of A1? A1 is A0 plus, how many over here? In this example, how many? 30. So A1 is equal to A0 y plus 30 into size of int, that many integers, that is 30 into 260. Here there are 30 integers. So 30 integers means 60 memory locations. So 30 into 260. So whatever is this A0, AI should be AI should be AI minus 1 plus n into size of int. Is not so? Is not so? But there is one small problem. If you add an address A0 plus 1, automatically it increments by 2. If you write A1 plus 1, automatically it increments by 2. So, do I need n into size of int? No, I need only n. I need only n, because AI is basically AI minus 1. A1 is basically A0 plus 30. 30 will automatically make it 30 into 260, because you are adding. When you add, what happens? When you add something with a pointer, automatically into 2 happens. When you write, when a pointer is say 0562, you add 1 to it, it automatically becomes 0564 because it is a pointer to an integer. So similarly, AI is pointer to an integer. If you add n to it, automatically n into 2 is added. So AI is equal to AI minus 1, that is A1 is equal to A0 plus 30. 30 integers automatically assigned. So this is automatically, this becomes A1. Now what happens? What is A2? A2 is again A1 plus 30, because there are 30 integers. So AI is equal to AI minus 1 plus n. Things work absolutely fine. No problems at all. So once this has been done, once this allocation has been done, next what? Next what to do? Next you can say that your array is absolutely ready. Now you can access any memory location in a normal way like Aij. Everything has been done. Aij can be accessed. How to free at the end? See, only free A will not do this time. Sorry. Only free A will not work this time. Free A will free this array. Remember, A means this array. So free A will free this array. But you need to free this also. Is not so? You need to free this entire array also. So you need free A0 also. You need one free A0 also. If you write free A0, then automatically that location which you had allocated is freed, because A0 you allocated like this, m into n into size of a int. So free A0 will mean freeing that entire this array, because A0 you allocated like this, m into n into size of int. So if you write free A0, then this whole thing is freed. Then free A will definitely work. Is not so? I think you understand. Now let me write the program then. So what to do, how to write this program? I will allocate an array like this, and then I will take some values from the user, and then I will print those values. As simple as that. Later on we may do some other programs of 2D arrays using pointers. So let's do this. In start a. Firstly this is done. Then I will ask from the user printf. Enter the number of rows, enter the number of rows and columns. Enter the number of rows and columns. So here /n, I expect user will enter two numbers. You have to scanf, %d, that same thing I am writing, whatever I have written just a while back. But you follow again. Scanf %d, ampersand aim and ampersand n. Once this is done, what to do next? Next, I know aim and n. So next job for me is firstly allocating the memory. This is int double star malloc what? Aim into size of int star. Aim into size of int star. Once this is done, next what? Next is allocation of A0. A0 is equal to int star, because A0 is pointed to integer. Malloc aim into n into size of int. Once this is done, then a for loop for I equal to 1, I less than m, that is for all these numbers. Check over here. For I equal to 1, from here to less than m. M over here in our example was 50. So for I equal to 1, I less than m, I plus plus. How do you get every I? AI is equal to AI minus 1 plus each of this n, this many integers. So AI minus 1 plus n. Is not so? Now once that is also done, next what? Next I will access. Now like AI is accessed as AI, as you know, is same as star of A plus I. So once you know all this, like address of AI is equal to A plus I in case of a 1D array. So is there any way Aij can be expressed? Aij, can it be expressed in some other way using pointers? See, yes it can be. See this. What is A32, like A32? See this, A32, or maybe you consider this, A23. What is A23? A23 is firstly you reach A plus 2. A23, see I am writing over here, A2 then 3. A23. What is this? You firstly reach over here, A2. A2, how can you reach? A plus 2's content, A plus 2. The content of that, the content of A plus 2 is actually an address QQQQ. So what is this QQQQ? This one. This one. You add 3 to it. This is A20. Content of A plus 2. Content of A plus 2 is this one. QQQQ. So content of QQQQ, again what is that? A2 itself. But if I add 3 to it, then where do I reach? The address where A23 is present. If I add 3 over the 3 to this, I reach the point where A23 is present. So if I add content of A plus 2, with that if I add 3, then I reach that address. What is the content of that address? A23. So check. The content of that is A23. So what is A23? Content of A plus 2 plus 3, content of that. See this once more. A plus 2, this is A. This is A. This is A plus 2. This is A plus 2. If this is A plus 2, content of A plus 2 is A2. So content of A plus 2, this one is A2. Plus you add 3 to it. Content of A plus 2 is A2, which is Q, 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 Q. So if this is Q, 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 this one is Q, 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 Q. You add 3 to it. You reach the address where A23 is present. So content of that, this address you have reached after adding 3 to Q, 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 Q. So content of that is A23. Is not so? Content of Q, 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 Q is A20. Q, 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 Q is A2. So content of A plus 2 is Q, 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 Q. Content of that is A20. If you add 1 to Q, 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 that is the content of that is A21. If you add 2 to Q, 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 then the content of that is A22. If you add 3 to it, then the content of that is A23. So this is how you reach there. This is what I have done over here. You see here. Where did I do it? Sorry. Where did I write A23 equal to A2 plus 3? I am just trying to find it out here. So A23, what did I do? Content of A plus 2, this one, plus 3 added to it. Content of that is A23. So generalizing, what is Aij? Aij is, because of this nature, it is content of A plus I. Add j to it. Content of that as a whole is Aij. So similarly you can say, what is address of Aij? Just the reverse of it. Address of Aij then is, if Aij is this, I'm sorry, this I made a mistake, the bracket will be here. Content of A plus I plus j, content of that. So what is address of Aij? So check out, address of Aij is, here if I put an address, then this star is not there. What is the address of Aij? It is star of A plus I plus j. Is not so? So here, once you have initialized all these things have been done. Next, what is to be done? Next, I will scan. So printf, enter the elements row wise. Enter the elements row wise. So a /n over here, and here I will now use a for loop for I equal to 0, I less than m, I plus plus. Then you remember, I will ask the user printf, enter the %d. This I was doing when I was doing 2D arrays. %d elements of the %dth row. Enter the %d elements of the %dth row. That is what I was doing. So /n, %d elements of %dth row. Each row contains how many elements? N elements in each row. And which row I am talking about right now? I. I is the row number, 0th row, 1th row, like this. So %d elements of the ith row, the n number of elements of the ith row. So over here, after printing this, in a for loop I must scan that many elements for j equal to 0, j less than n, j plus plus. What did I do? Scanf %d ampersand aij. This, instead of writing ampersand aij, what can you write? You can write star of a plus I plus j. Is not so? So this whole thing is done now. So now I can, once this is scanned, the elements are scanned, now only thing I need to do is print. So I will just copy this whole thing, paste, and then do the necessary changes for printing. I paste this. Now the elements of the array, just I will write. The elements of the array are the elements of the matrix. Let me call it matrix. The elements of the matrix are /n for I equal to 0, I less than a, I plus plus. This is fine, this is not needed. I will just print it row wise. So the 0th row is printed over here. Aij means 0, 0, 0, 0, 1, 0, 2, 0, 3. So the entire row is printed. After printing one row, what I need to do, you remember? Printf /n, so that the next row is printed in the next line. Printf /n. But after printing each element, 2 gaps maybe. And it is better if you print it as %, maybe 3D. Three spaces you take and print. In this way, you need to print, but this is not scanf, this is printf. And this is not ampersand aij, but only aij. And what is the meaning of aij? It is same as star of a plus I, and then putting an entire star outside it. So this way the whole thing can be done. Let me run this program and see that it is running properly. But what elements you have used, just need to declare those. I, J, M, N, all this you needed. You need to declare those. These are extra we had written to explain. Let me comment out. And then you need to do this thing. Over here the commenting. So over here a comment, and this whole thing has to be commented out before #include stdio.h. Okay, so let me run this program now. Let's see what it does. Oh, one thing you forgot, free. So free is needed. Free A0. Once you free A0, firstly free A0, then you free A. Because if you free A first, then you lose A0. Isn't it so? So firstly free A0, then free A. Because if you free A first, look at this. If you free A, then this whole thing is gone. If this whole thing is gone, then your A0 is lost. If your A0 is lost, then this address is also lost. You cannot free A0 also. So firstly free A0, then you free A. That is, firstly free this entire set, accessing it by A0. Then you free this whole thing, accessing it by A. So let me run this program now and see what happens. Alt-R, enter. Enter the number of rows and columns, 3 and 4. Enter the elements row wise. 4 elements of the 0th row. Let me say 1, 2, 3, 4. 4 elements of the 1th row. 3 such rows are there. 2, 3, 4, 5. 4 elements of the 2th row. 3, 4, 5, 6. So 3 rows are there, done. Now the printing has to happen. The elements of the matrix are 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 6. Absolutely correct. So I think you understand how to do it. This is the relation between 2D arrays and pointers. You can try out this whole thing. Okay. But if you are interested, you can also print these different addresses and find out that it is happening that way only. Okay. So this whole thing can be done. You could have avoided int *a and written int a nn. If you write int a nn, then this malloc is not needed. This for loop of assigning the addresses are not needed. This whole thing is same as int a nn. See, int *a followed by this malloc and this for loop to assign the addresses are same as doing int a n. Also the 2 frees were not needed then. But you have done the whole thing only to save addresses and to allocate exactly that many number of memory locations which you need. It's not so. So you have understood this. You run this whole thing once again. You check out, you do all sorts of things with it. When we come back, we will do with some more programs with 2D arrays. Thank you so much. We will come back after a bit of break.